Professor Dr. N. Ganesh is working as a senior faculty, Department of Computer Science and Engineering, SRM University, City Campus, Vadapalani, Chennai. He has more than 12 years of undergraduate and postgraduate teaching experience, which includes 5 years of research experience. He has trained many corporate batches on technologies such as mainframes, Application Systems 400, SAP, ABAP. He has published 10 articles in both international and national journals. He has presented several papers in both national and international conferences. He has written 4 books which are prescribed in Anna University affiliated colleges, SRM University and Bharat University. His research interests are software engineering, data mining and cloud computing.
Welcome to UGC lecture series in computer science. We are going to see a series of lectures in the subject operating system. This is for the students studying in the 5th semester of their BSc degree program. So, we are going to see topics from Unit 1. So, out of the various topics listed in Unit 1, in this session, we are going to see how a process has been created, how a process has been terminated. We are going to see topics on the process management. In the process management, in this session, we are going to see how a process has been created, how a process has been terminated, and then what is a cooperating process, and then about what is an inter-process communication. So that is for today's session, and the contents will be like the process creation, the process termination, inter-process communication, and the communication models, different types of communication models, examples of inter-process communication system, the communication in the client-server system and its types, the different ways of communicating in the client-server system we will be seeing in today's session. Now, what is a process creation? In the earlier session, we have seen about what a process is, how it is, what is a fork is, how a child process has been created, and then we have also seen what are the different process states, and in this session we will be seeing how a process has been created, how a process has been terminated. How a process has been created. A parent, or what is a parent process? Parent process is one which creates a child process. So what happens is that a parent process usually creates a child process, and that child process creates another process. So that process creates one other process. So it forms a tree structure. So first, basically this parent, it creates one child, and that child creates other child, that child creates other child. So this is a tree structure. So this is how the process has been created, and each process is been given a unique process ID that is called as a PID. So the parent process creates children process, which in turn creates other process, forming a tree of processes. So this process, each and every process is identified with an identifier called as PID. And then, so this process creation has the following topics. One is the resource sharing, how a resource is being shared, and then we are going to speak about in terms of execution, and then we are going to speak about in terms of the address space. So now, what is a resource sharing? How a resource has been shared? So this parent, it will be, here it is. So this parent and children, it shares all the resources. So these are the 3 different conditions. So first condition is this parent and children share all the resources. So equally the parent will be using the resource whatever the child is using it. And then the second condition is the children share the subset of parents' resources. That is, parent will be the superset, and whatever the parent gives the resource for the children, that those resources will be used by the children. So this children share subset of parent resource. And the third condition is parent and child share no resources. That is, no resource, the parent will be using its own resources, child will be using its own resources, but those resources will not be shared. That is for a resource sharing. Then is the execution. in the term of execution, parent and children execute concurrently. And then for the second instance, the parent will wait until the children terminates, because this child has been created by the parent. So parent always it is a superset of that particular child. So the execution time taken by the child will be comparatively less when compared to the parent. So this parent will be waiting till the child process gets terminated. That is the second point as far as an execution is concerned. Then about the address space. In the address space, the child duplicates the parent. That is, I gave you an example for a Unix. So it shares separate. In a previous session, we are seeing an example of a Unix operating system wherein the child process will be getting a separate address space as that of a parent process. So here, or in this case, the child duplicates of a parent. So a same similar address space will be created for in the memory space. That is child duplicates of parent. Then the second condition is the child has a program loaded into it which is of its parent. So this Unix example has been listed over here again. The fork system call creates a new process. EXEC is nothing but the execution system. Execution system call is used after a fork to replace the process memory space with a new program. So here we will see with a diagrammatic view of how a parent how a process has been created. So as I said, the parent will be waiting for the child process to terminate, and if it terminates, if all the process pertaining to the child gets terminated, so it goes to the parent, and then the operating system what it does is it goes to the parent, it notifies the parent, and then the parent, if it says that okay, all the process of the child gets terminated, then it informs the operating system, and then the memory space is freed out. So that is how it works. Now we will see this as on a diagrammatic basis. Here it is. The fork, what happens is that there is a parent, there is a child. So in the child you have an EXEC. EXEC is nothing but it is used for the execution of the process pertaining to the child. So after completing this process, after the child gets executed, it goes to an exit phase. So when it goes to an exit phase, this process, it will not be terminated by and large. So what happens is that this OS, it intimates the parent. So it informs the parent, and which is there in the wait state. So this exit state goes to this wait state, and if the parent gives a final confirmation, then it exits and comes out, or this child alone will get exited and the parent will resume its own job. If the parent is also completing its process, then it will inform the operating system wherein the memory will be deallocated. This is for a parent creation. This is for a process creation. Then we will see how a process has been terminated. What do you mean by a process termination? The process termination is something but which is at the last stage. That is, if the process has been executed, if the process is coming to a concluding stage, then it calls the exit command, it calls the exit system call, and then it terminates. So this is how it is. The process executes last statement and asks the operating system to delete it. So output data from the child to parent via wait, which you have seen in the previous slide. In this slide, it is via wait. So then the process resources are deallocated by the operating system itself. Then this parent may terminate the execution of the children process. So after this, it goes to a wait state. So here this parent has every right to terminate this children's execution, this child process execution, because it has executed, it has come to an exit state, this has been informed to the parent, and this parent kills the child's execution, and then the child has exceeded the allocated resources. Then the task is assigned to child is no longer required. If the parent has completed its execution, the parent will also exit. So some of the operating systems do not allow the child to continue if the parent terminates. So what happens is that the parent is the superset and child is said to be the subset. Usually the operating systems will not allow the, supposing the parent terminates, it will not allow the child to work out its process. So that child process will be stopped abruptly. So it will be aborted. This is because child process is a subset of the parent process, wherein the parent process is said to be the superset. This is common in most of the operating systems. So all the child gets terminated. So this kind of termination, we call it as a cascading termination. A cascading termination is one wherein all the children gets terminated, is called as a cascading termination. Then next topic is on inter-process communication. What do you mean by inter-process communication? From the name implies, that is, two or more number of processes communicate internally, that is mutually. That is called as an inter-process communication. So how it communicates and what happens during its communication, we will be saying it. Here it is. The communication maybe it will be of two types. One is it will be an independent communication, or it may be a cooperating communication. What do you mean by independent communication? Independent communication is, say for example, we have two different processes. This process is communicating independently, and this process on the second process is communicating independently, and that is called as an independent communication. Cooperating communication is these two processes combine together, and when process 1 is communicating, this process 2 will be in the idle state, and when process 2 is communicating, this process 1 will be in the idle state. So this has a link. So these two processes will be syncing together and it will be communicating, because at a time only one process will be executing and at one single instance of time. So such a communication we call it as a cooperating communication. So what are the reasons that are required for a cooperating communication? If you are going to have a cooperating communication, then we can have the information sharing, and the computation will be speeded up, and we have a modularity, and the convenience will be better. So as far as an inter-process communication is concerned, it is of two types. One is the shared memory, other one is the message passing. What do you mean by shared memory? A shared memory is one, there will be a single memory, and this particular memory will be shared by these two processes, and the other one is the message passing. Message passing is we will be having a common mailbox. So whatever message we have, that will be sent to a mailbox, and from the mailbox we the other process will be intimated. So such a communication we call it as an indirect communication, which will be seeing it in the near future in this session. So about a shared memory, let us see this example on a diagrammatic basis. So this is a process A, this is process B, and this is said to be a kernel. What is a kernel? Kernel is the nucleus of an operating system. Say for example, I will tell you in a layman example, we have a coconut. So in the coconut, when you break open the coconut, you have the internal part of the coconut, you have a white structure. So that is said to be the kernel, that is said to be the nucleus. So as a coconut as a whole, we will not be in a position to eat it. So one and only you will be in a position to eat one and only if you are going to break the coconut into two halves and take the whiter part. So that whiter part you call it as a kernel, that is said to be the nucleus. So that is said to be the nucleus of an operating system. So in this diagram we have the kernel over here, and we have a memory for the kernel. We have two different processes. In both these processes we have separate memories available. So this memory is being shared over here, and it will be put on the kernel, and from the kernel this process B uses this memory. So this is an example for a communication model. So with this we will have a small break, and after the break we will see about more details on the cooperating processes. Welcome back after the break. So we were discussing about the communication model. Now we will be seeing about the cooperation processes and the advantages of using this cooperation process. So as far as this cooperative process is concerned, here are these advantages. We have an information sharing. So we have a common memory. So the information has been shared between these two processes. So when there is a sharing of information, then definitely we will be having a faster execution. So both these processes know what is there, what is here in this process B, what is there in the process A. So with this we can have a faster execution, and then so that increases the speed of the computation. Then there is a better modularity, and there is an ease of use, convenience level. So that is about a cooperating process. Then the next concept is about the producer consumer problem. What do you mean by a producer consumer problem? A producer is one which is producing the processes. So a producer will be keeping on producing the processes. A consumer is one which consumes the processes which is being produced by the producer. So such a kind of problem you call it as a producer consumer problem. So wherein whatever the process A, it will be produced by a producer and you get an end result, and that end result will be consumed by this process B, is called as a producer consumer. So here it is. So it is a paradigm of the cooperating process. A producer produces an information that has been consumed by this consumer process. So it is broadly classified into two types. One is called as an unbounded buffer, other one is a bounded buffer. Unbounded buffer is there is no limitation for the producer to produce the information. So that producer will be producing as much as possible information, and there is no limitation of the size of the buffer. Whereas in the case of a bounded buffer, there is a fixed buffer size. That is, this producer will be allowed to produce only a limited set of information. So till the buffer space gets filled out, this producer will be producing, and only those details can be consumed by the consumer, not like the unbounded buffer. Then, so this is one part. The other part of the inter-process communication is the message passing. How a message is being passed from one process to the other process. Say for example, if there are two processes, one process named P, the other process named Q. So how the messages are being passed? Let us see a problem over here. So if process P and Q wish to communicate, they need to establish a communication link between them. They have to exchange messages via send and receive. So establishing a communication link requires two parts. One is either the link can be established on a physical way, or the link can be established on a logical way. What do you mean by a physical way? A physical link is like devices. So link that has been used with the help of certain hardware properties, or a link that has been used with the help of a shared memory, that is called physical link. Then if it is of a logical link, logical way, so some sort of logical properties, usage of certain logical properties, you call it as a logical link. So these are the two ways in which a message could be passed. And then we have seen about the inter-process communication. So in which we will be seeing the different ways of communicating using an inter-process communication. So there are two major ways of communicating in this inter-process communication. One is called as a direct communication, other one is called as an indirect communication. What do you mean by a direct communication? A direct communication is one wherein you will be having a link, a physical link, and the communication will be taking place automatically. The link will be created automatically, and the communication will be taking place automatically from the sender to a receiver. Say for example, if there is a sender A and a receiver B. So if there is a physical link, if it is a wired transformation, so if there is a link between A and B through wires, then you can expect a lossless packets. The packets will not be lost when we are communicating from this position to the other position. So that is the reason when two people are talking in their telephone, usual BSNL landline telephones, their communication will not get lost. Whereas in the case of when people are going to talk in terms of the mobile phones, the communication may get lost. There is a possibility of a loss in communication because it is wireless. Whereas in the case of direct communication, it is a wired communication from the sender to a receiver. So that is one thing. So in which the processors has to name each other explicitly, then only you can have a proper communication. So the links are established automatically. A link is associated with exactly one pair of communicating process. So usually this kind of communication is said to be a unidirectional communication. But even then, even the bidirectional communication is also possible, but this direct communication is exclusively meant to have the unidirectional communication. But in other words, but even we can use it for a bidirectional communication, but it is meant for unidirectional communication. Then the other type of communication is called as an indirect communication. In the direct communication, you had a link between the sender and the receiver, direct link, and we have a communication, automatic communication. Whereas in the case of an indirect communication, it has been communicated through a mailbox. So that particular sender will be sender A, he will be sending it to one particular mailbox, and the receiver will be receiving the contents from that mailbox. Say for example, I have a question. Say for example, if that particular sender process, if he is going to send it to other processes, if P1 is going to send to two processes at the same time, P2 and P3, then which process will be receiving it? So that will be determined by the operating system. So how to receive those processes? So what happens is that this P1 will be sending at one instance of time. This P2 and P3, what happens? So only at one particular instance of time, only one process can receive the information. So either P2 or P3, whichever gets first, will be receiving it. So it will not be received by both the processes. So that is a drawback, even we can say, for an indirect communication. So because it has been determined with the operating system. So here it is. So the properties of an indirect communication are the link established only if processes share a common mailbox. The link may be associated with many processes. Each pair of process may share several communication link. Link may be unidirectional or bidirectional. So this indirect communication we can use for a bidirectional link also. So this is the example which I stated now. So one is P1, P2, P3 share a common mailbox. That mailbox is named as A. So P1 sends a message to both P2 and P3. So which process, that is P2 or P3, which process will receive the message that has been sent by the process P1? That was my question. The solution is here. It allows a link to be associated with at most two processes. So allow only one process at a time to execute to receive the operation. So always at one particular instance of time, only one process can one process can get executed. So allow the system to select arbitrarily. System in the sense it is the operating system, to select arbitrarily the receiver. The sender will be notified who the receiver was. So this is how a communication takes place in an indirect communication. So in this indirect communication, it has been taking place with the help of a common shared mailbox. Whereas in the direct communication, there will be a link established between the sender and the receiver. Then let us see the examples of an inter-process communication with respect to a Windows XP. So here, this Windows XP, the message is being passed via a local procedure call. It works only between process on the same system. It uses ports. Port is nothing but the mailboxes to establish and maintain communication channel. We will see on a diagrammatic basis. So the communication will be working as follows. So this is how. So this is said to be a client and this is our server. So in this client, a connection has been requested and you have a connection port. I suppose you might be knowing what a port is. A port is something like an 8080 or 1625, which you will be seeing it in terms of the communication pipes. So here the connection has been requested and it has been handled to a server. So here we have given the client opens a handle to the subsystem connection port object. The client sends a connection request. The server creates two private communication port and returns the handle to one of them to the client. The client and server use the corresponding port handle to send message or callback and to listen for replies. So it creates two server ports. One is the server creates two ports. One is to handle the port, other one is to handle the communication. So what happens is that the server communication port, it gives it to the client communication port, and this from this port the messages are being shared to this client, and this is how the communication takes place. So based on the shared object, the communication between the client and server takes place, and this communication, it will be usually less than or equal to 256 bytes. So let us see what are the different ways of communicating in a client server system. There are 4 different ways of communicating between a client server system. One is a socket communication, second one is a remote procedure call, or it is otherwise called as RPC. Third type of communication is called as a pipes. Fourth type of communication is called as the RMI. RMI is which we use it in our Java. RMI is nothing but remote method invocation. Now let us see the first communication, the socket communication. What do you mean by a socket communication? Socket communication is one which will be used to communicate between a sender A and the receiver, sender and a receiver. So it will be communicated using an IP address. I suppose you might be knowing what an IP address is. IP is nothing but the internet protocol address. So supposing if I am going to type as www.google.co.in, and if I am going to press an enter in my web page, so definitely when it hits the web page, web server, it will not be going as google.co.in, wherein it will be going with the IP address. So that each and every IP address will be given a port ID. So we will see it in a diagrammatic basis. So this is how it is. So this is a socket. This is said to be the IP address 146.86.5.20. So this is said to be a host, wherein :1625 is said to be the port ID, and this is said to be my web server ID. This is my web server IP address 165.25.19.8, and :80 is said to be the port address of this web server. So communication takes place in this manner. So a socket is one which is defined as an endpoint for communication, and concatenation of IP address and port is to be done. So wherein, as I said, this is said to be the IP address and 1625 is said to be the port. So communication consists between a pair of sockets. So next is about the RPC. RPC is a remote procedure call communication. We have stubs. So the stub is used for both for the we have a client stub and the server stub. So in this client and server, the message will be passed. So that parameter we call it as a marshalling. So we pass the message from the client stub and the server stub. So this is one other communication channel. So we have one other communication channel by named pipes. We will be seeing more of the pipes, and there are two different types of pipes. One is called as an ordinary pipe, other one as a named pipe. So we will see more details about pipes and its communication in our forthcoming session. Now let us have a summary of what we have seen in this session. We have seen how a process is created and how it gets terminated. We have learnt about the inter-process communication. We have studied about the different communication models, that is about the direct communication, indirect communication. We have seen certain examples of an IPC system with respect to Windows XP operating system, and we have learned two different communication channels that has been taking place in the client server system. One is on the socket, other one is the RPC. So let us see the questions related to this particular session. One is, what is a process creation? How is a process terminated? What is direct communication? What is indirect communication? What is message passing? list few communications taken place in the client server system, communication channels taking place in the client server system, wherein we have seen 2 communication channels. With this, we conclude this session. So we will see more about these topics in our forthcoming session.